Okay, so we're going to perform a linear regression. We're going to get the results of a linear regression. So comparing two sets of variables and getting a correlation coefficient, an R value, a P value, which is a probability of error, the slope and the intercept of a line of best fit through the plotting of two sets of data. So in order to do a linear regression, we are going to need to have a data frame, or we're going to use a data frame in this case. So we're going to import pandas first and alias that as PD. We're then going to import a function called linregress. So we're going to use a function called linregress. The function is in a library called scipy, and scipy holds a wide range of scientific functions. It has a sub-library called stats, which holds the stats functions within that wider library. And in that stats library is a function called linregress, which is what we want to use. So rather than importing the whole of scipy stats, what we're going to say is from scipy.stat, so from the library that we know that this function is in, import linregress. And what that means is we are only importing that one function from that library, and that is really useful. So we've imported our libraries, or we've imported our function, and we've imported the pandas library. We are going to write a function that will get a linear regression. Let's start with that, and it will need a data frame to get the linear regression from. So we're going to start the program down here. Let's start by setting up a URL, which is the URL of the data set we're looking for. And then let's get a data frame. So this one's about income. The one that we're working with is income data. So income df, we'll call our data frame income df, and it's going to be a pandas read, and it's an Excel file, so we need to use read Excel, fit the URL, and this has got a number of sheets in it, and the sheet name that we're interested in is called county level with a hyphen in the middle. Okay, just before we do anything else, just going to check that we've got that. And I've got an indentation error. Now the reason for that is because I've got a function, and that function hasn't got any instructions in it. So as far as Python's concerned, or the interpreter is concerned, it was expecting the next line to be indented, which it wasn't. So I'm going to run that again, and this time it's run. So we've got our data, and that's what it looks like. So we're going to see if there's any correlation between, let's see if there's any correlation between the level of population and income. So maybe if there's a denser population, the income's generally smaller. That would be something that we might feel that there might be a correlation between. So we'll do the two of those. So our independent variable is going to be income, and our dependent variable is going to be population. Sorry, our dependent, the other way around, I think. And it's population and income that we're going to be looking at. So what we need to do first is we've got our data frame, and we need to send that off to the linear regression function and get it to do the thing that it needs to do. So ideally what we want to do here is we want to say get linear regression, and in there we need to give it the data frame that we want it to work with, and ideally we actually want to tell it what two columns we want it to work with as well. So if we say population and income, okay, so there's the two columns that we want to correlate. So let's go ahead and do this function, write this function now. I don't need to pass anymore because I'm going to put some actual things in now. So first of all, I need to show here that I've got two sets of data to correlate. So data set 1, data set 2, or data column 1 and data column 2. So I'm going to, first of all, I'm going to get those two lots of data. So my X, I'm going to call them X and Y, the two data sets. First one is coming from that data frame, and it's coming from that column. So Y is coming from that data frame and the column that's called data 2. We've got X and Y, that's our first two things. And then what we need to do is to run the linear regression. So what we're expecting is that we're going to get a set of values back from that. So we're going to, let's call this variable, we're going to store it in linear reg. And that will be the result of linregress with two variables, X and Y. And what we'd expect is that if we return linear reg, then we will just get a printout at the bottom. That's the value that we'll get back from the function. So let's run that and see if that's working. And there it is. So we've got a linear regress result. It's given us a slope, an intercept, an R value, a P value, and a standard error. We are probably, if we're going to be trying to find a line of best fit, there's only actually there's two parts of this that we're interested in, and that's the slope and the intercept, because we can then create a line of best fit from that. And so we would probably only want those two. We are obviously interested in the R value and whether that looks like it's there's a reasonable correlation. We're interested in the P value in terms of whether there's a probability of error. This is actually reasonably high. And then the average error, that's the average kind of distance of each point on the plot from the line of best fit. So we're interested in those two coming back. So if all we want to get back is those two things, then we can just, instead of returning the whole of the linear regression or linear reg, we can say, let's return linear reg slope and linear reg intercept. And what we will get then is something that looks like this. So that's just those two things. And if we want to further keep those in some variables down here, we might then say, let's say slope and intercept will be equal to that. We should be able to print both of those. So what we've now said is that the function is going to, instead of returning the whole result of the linear regression, it's going to return the slope and the intercept. We are going to run that function and it will return two values, which we will put in the same order into two variables, which we can then print. So I should get those two numbers, but one underneath the other, not in any sort of groups in any sort of set brackets or anything. So we've now got our two variables from the line of best fit, the slope and the intercept, and we can now actually plot that line.